Many people, including my students, are asking whether learning Python is still worth it today because of the rise of GenAI tools and the opinions of prominent figures like NVIDIA CEO Jensen Huang.
It is our job to create computing technology such that nobody has to program.
I am 40 years old. I know, I don't look a day over 30. Thank you very much. My age is relevant because I have experienced several tech hypes, and I have no reason to believe that the GenAI hype is any different from the previous ones. For example, since the early 2000s, I have heard that fully autonomous self-driving cars would soon take over the roads, eliminating the need for driver's licenses. In the 2010s, I heard that radiologists would become obsolete because all our medical images would be analyzed and diagnoses made by machine learning models. We were also told that crypto and blockchain would replace the traditional banking system. While technological advancements and new innovations have certainly changed our lives over the past few decades, the impact is often less dramatic than the hype would have you believe. Keep in mind that CEOs' jobs are to sell an idea or a vision for the future to you and to the investors, not a fully formed product. Whether that idea will eventually become reality is a whole different question. All the eye-catching headlines about coding becoming obsolete because of GenAI will write code for us, I don't think that's going to happen. It is just another hype that will eventually quiet down. Coding will certainly change, don't get me wrong, and people will use different tools a few years from now than today. But that has always been the case. Tools, even programming languages, come and go, and I will come back to this point after the next one. Python is a general-purpose language. This means that while Python has a variety of capabilities, it is not the best tool for most of them. You can design games and web and mobile apps, you can automate processes like web scraping and data collection. However, it is not great at most of these things. You can certainly find tools and languages better suited for each of the tasks I have listed. Where Python really shines is in machine learning and deep learning, which is why Python is a required skill for most data jobs. For some reason, Python has become the most popular programming language in the machine learning community over the past decade. Packages like Pandas, Matplotlib, NumPy, Scikit-learn, Keras, TensorFlow, PyTorch, and many others have no rivals or equivalents in other programming languages, ensuring that Python will remain the dominant language of data science for at least the next couple of years. Python's syntax focuses on readability and ease of use, making it a first-grade language to learn. I learned C at university, and honestly, it was a nightmare. My brain quite literally melted when we learned about pointers that point to pointers. No offense to any C coders out there, but what the fork is that about? It took me a semester to get to a level where I could read in a CSV file and implement simple numerical methods. In contrast, these tasks are much easier in Python. Learning Python is easy because you quickly achieve tasks, providing positive feedback that motivates you to keep going. Python also has strong community support. There are a ton of tutorials and training materials available. Most packages are very well documented as well. Stack Overflow or GenAI tools are great resources to help you debug your code. I've been coding in Python for more than 12 years by now, and I haven't come across a problem that hasn't been solved by someone else on Stack Overflow before. The main cons of Python are that its performance is weak compared to other languages and it is not natively parallel. While it's easy to write code, it takes a lot of effort and deep knowledge to optimize for runtime or memory performance. There is a lot of active research and development going on to address these cons. One example is Mojo. Mojo is a new programming language under development that aims to combine the usability of high-level languages like Python with the performance of low-level languages like C and C++. As much as I hate it, let's talk about my age again. I have used more than half a dozen different programming languages so far, and I'm quite certain I will learn a few more in my life. I started coding in elementary school back in the 1990s using a language called Pascal or Basic, I think. My memory is a bit hazy about that. I didn't do much coding in high school, but as I said, I learned some C at university. Back when I was an astronomer, I first used a language called IDL, which is short for Interactive Data Language, which was huge in astrophysics back in the day. Lots of packages to work with and visualize astronomical data were developed in that language. Then I used Fortran during my PhD because I worked on novel numerical algorithms, so I needed a low-level and computationally efficient language. Then I switched to Python during my postdoc years, so I could take advantage of packages like Pandas, NumPy, and Matplotlib, and later, of course, the machine learning packages like scikit-learn and others. While I use these three languages the most, I also worked a bit with R, MATLAB, SQL over the years. This shows that you don't choose a programming language for life. Programming languages are tools, and you choose the tool that's best to solve the problem you are working on. If the problem happens to be machine learning, Python should be your choice. If your goal is something else, you might need to find a better language. The great thing about programming in general is that once you are familiar with one language, it will be so much easier to learn a second or a third language. Coding concepts don't really change from one language to another. The main challenge will be to learn the new syntax. Programmers are some of the smartest and laziest people, and I really mean that. The goal of programmers has always been to make their work easier. That's why new languages and tools are being developed all the time. One of the main drivers behind the creation of new programming languages and tools is to increase efficiency. The whole point of software development is to solve problems and automate tasks, making life easier for people and businesses. New languages and tools are created to address specific needs and gaps that existing ones cannot fill. This constant evolution is part of the beauty of the tech industry. It never stands still. GenAI and other advanced tools are just the latest in a long line of innovations aimed at increasing efficiency. However, they are not replacements for foundational skills like coding. Instead, they are enhancements that can help us work smarter and faster. Knowing how to code, especially in versatile and powerful languages like Python, gives you a solid foundation to leverage these new tools effectively. So, is learning Python still worth it in 2024? Absolutely. Despite the hype around new technologies, Python remains a valuable and powerful tool for many applications, especially in data science and machine learning. It's easy to learn, has a strong community, and it's backed by a wealth of libraries and resources. While the tech landscape, languages, and tools will continue to evolve, the fundamentals of coding and problem solving will always be in demand. If you enjoyed this video, click the video on the screen to figure out if data science is for you. Happy coding!